Okay, welcome back. You ready? In the last video, we compared different time periods in making linear regression models. We chose the one with the highest R-squared because it's the best at predicting what we've got going on in our data. And now we're going to move forward and we're going to make a forecast. So if you've been following along, we made a moving average 3 forecast, a moving average 5, an exponential smoothing forecast, and we're about to do linear regression. So to start, I'm going to drag this bad boy down here. And I'm going to head over to my moving average 3 forecast. And I'm going to copy my whole section with my forecast and my errors. I'm going to bring it over to my linear regression tab. I'm going to line it up and I'm going to paste it. So of course, we don't have a moving average 3. We've got linear regression. And these averages will be limited. Well, it's referencing everything that we've got. So let's just change these averages really quick in case we make some sort of change to our data. All right. So we're ready to make our linear regression forecast for 2024. The parameters of the model that best fit our data for me is here. I've got a slope of 12,000, increase 12,000 visitors per year. My intercept is this very large negative number, because if you had to go back all the way to year 0, 0 to make this line hit, we'd intercept at negative 24,000, and our R-squared is 0.4974, or telling us that roughly 49% of the variation in attendance is just explained by that time trend. So let's start by predicting what our forecast would be if we used this method for 2024. So we're going to have our linear forecast equal to our intercept, Command T there, because that will make it sticky, plus our slope, Command T again, multiplied by the year. So the linear regression forecast for 2024 is 1,076,248. And again, to know if this model's good, we're going to plot where that line is for this whole time period, and then we'll calculate our forecast errors, our absolute forecast errors, right? All of these error metrics, and then we'll compare them. So the linear regression forecast for 2006 would be equal to the intercept made sticky plus the slope made sticky multiplied by the year. It's just entering that formula again. You could drag it up, but you drag that formatting and that works too. So when I drag that linear forecast down, you can see that there's an increase every year, right? Because it's just plotting that line. It's plotting this line exactly here, right? So these are just all the points on that line. And then our errors, the difference between our actual and our expected, right? In the first year, it looks like our model was greater than the total, so our line would be above the actual point by 8,000. And we can see that here, but look, it looks like it's right on the line. Some of these years where we were really far away, we didn't do great at picking up the post-pandemic jump or the pre-pandemic or the early pandemic drop. So here you can see, right, 2020, we were off by quite a lot, because we overestimated how many guests would have been there because we didn't realize there was a global pandemic. And then the next year, we didn't realize that there was going to be a global pandemic that drove everybody into the wilderness, right? We can't predict that in advance. So basically for our model, that looks like noise. I'm going to steal my formatting place it here. Oh, I tried. Steal my formatting. Place it here. Okay, there we go. So now let's take a look at our errors. The mean forecast error in a linear regression model is 0 by definition. It sets the line such that the errors, overestimations and underestimations always balance themselves out completely. So the linear regression model is going to be an unbiased estimator. It's not going to overestimate or underestimate. The absolute percentage error looks small, but I think that's just an issue of formatting. Right, 5.2%. So it's unbiased. It doesn't overestimate or underestimate. It's off, or it has been off by about 51,000 per year, and that translates to an absolute percentage error of 5.2%. So now we've made forecasts for each of these 4 models. And we've got to decide which one is going to be the one that we're going to use. So there's MA3, there's MA5, there's exponential smoothing, and there's linear regression. So to make our comparison, we're going to come back in the next video and make a table that lines up all of our forecasts, a visualization of them, and their errors side by side. And it'll be able to help us see which one did a better job, and that'll be the one that we move forward when we forecast the entirety of our data set, or when we forecast the entirety of the year 2024. Okay, that was much faster than I was expecting. Happy calculating.